Texas is known for its heat, with long blazing summers and mild winters that rarely see a snowflake. Most people picture Texas as a place where the sun beats down relentlessly and air conditioners work overtime just to keep up. But this January, the state is shivering under layers more suited for Minnesota. Texans are swapping their flip-flops for snow boots, and the familiar sight of shorts and t-shirts has been replaced by heavy coats, scarves, and gloves. For many, it's a shock to the system. The culprit? A polar vortex, an enormous mass of Arctic air, has broken loose and swept deep into North America. This isn't just a cold front. It's a powerful, swirling system that can bring record-breaking low temperatures to places that usually stay mild. Normally, this frigid air spins tightly around the North Pole, kept in place by strong winds called the polar jet stream. But sometimes the system wobbles, and a chunk of that cold escapes south, slipping past the jet stream's grip. This month, that wobble sent Arctic air plunging across the U.S., turning Texas and much of the South into a winter wonderland, complete with snow, sleet, and freezing rain. Streets that are usually busy with sun-seekers are now blanketed in white, and palm trees are dusted with frost. The result? A historic winter storm, with impacts stretching from Oklahoma to the Carolinas. Highways have turned into icy ribbons, and cities unaccustomed to snow are scrambling to keep up with the sudden freeze. This isn't just about grabbing an extra blanket, it's a reminder of how connected our weather systems are. What happens at the top of the world can quickly ripple down and change daily life thousands of miles away. The same air that was over the Arctic Ocean days ago is now freezing pipes in Austin, causing headaches for homeowners and city workers alike. The cold has disrupted daily routines and even threatened critical infrastructure. So, what exactly is a polar vortex, and how did it end up here? Why does it sometimes break free and travel so far south, catching everyone off guard? We'll break down the science behind this icy invasion, explore how meteorologists track it, and see what it means for all of us. Understanding these patterns can help us predict and prepare for future cold snaps. Understanding these events helps us prepare for the unexpected, from stocking up on supplies to protecting our homes and families from the cold. So grab some hot cocoa, bundle up, and get ready. Let's dive into the wild world of winter weather and discover what makes these Arctic blasts so powerful and unpredictable. Weather is a wild ride, and sometimes even Texas gets swept up in the storm. The polar vortex isn't science fiction. It's a real and powerful part of our planet's climate system, shaping the weather in ways most of us rarely notice until it makes headlines. Imagine a spinning cap of intensely cold air, anchored at the North Pole and swirling high above us in the stratosphere. This isn't just a local phenomenon, it's a vast dynamic system that circles the entire Arctic region, acting as a kind of icy crown for our planet. The polar vortex is at its strongest during the winter months, held in place by the polar jet stream, a high-speed river of air that snakes around the globe. Think of the jet stream as a powerful invisible fence, keeping the coldest air bottled up near the pole. When this jet stream is strong and stable, the Arctic chill stays locked up north, and much of the northern hemisphere enjoys relatively mild winter weather, sometimes even unseasonably warm spells. But if the jet stream weakens, shifts, or starts to wobble, the polar vortex can become unstable. It stretches and distorts, sending frigid lobes of Arctic air plunging southward, sometimes reaching areas that rarely see such cold. The vortex itself is enormous, spanning thousands of miles, and while it's invisible from the ground, its influence is felt across entire continents, shaping weather patterns and temperature extremes. Normally, this swirling mass keeps the Arctic air contained, but when it's disturbed, it can unleash a deep freeze that sweeps far from the pole, catching cities and regions off guard. These disruptions are the first step toward the kind of Arctic outbreak we're seeing now, sudden, dramatic, and often unpredictable, with the power to transform local weather overnight. It's a delicate balance, one that can tip quickly, with just a small change in the jet stream setting off a chain reaction that affects millions. When that balance is lost, the results can be dramatic: blizzards, record-breaking cold, and winter storms that paralyze entire cities. That's how places like Texas, which are usually mild in winter, can end up colder than parts of Alaska, with snow and ice transforming familiar landscapes into something almost unrecognizable. Let's take a closer look at how this played out in January 2026, when the polar vortex made headlines and changed daily life for millions across the United States. In January 2026, a sudden stratospheric warming event over the Arctic disrupted the polar vortex. This rapid warming weakened the vortex, causing it to wobble and break apart. The jet stream, usually a barrier, became wavy and unstable, opening a path for Arctic air to surge south. Meteorologists at NOAA saw this coming, tracking the cold air as it spilled from Canada into the U.S. The result, a slow-motion river of frigid air sweeping across the continent, targeting regions unprepared for such cold. This wasn't a brief cold snap. It was a prolonged, dangerous freeze. Forecasts warned of persistent, record-breaking lows, with the vortex lingering over North America. Millions faced days of extreme cold, a stark reminder of the atmosphere's power. The event's scale and duration made it historic. It's a vivid example of how quickly weather patterns can shift, and it all started high above the Arctic. The Arctic air's journey south brought record cold to Texas and Oklahoma, states more used to heat than snow. Roads iced over, power grids strained, and temperatures plunged into the single digits. As the cold spread east, states like Louisiana and Alabama faced hard freezes, threatening crops and infrastructure. The storm continued into the Carolinas, bringing ice, snow, and widespread power outages. Even the Northeast felt the chill, with cities like Philadelphia seeing temperatures far below normal. The wind made it feel even colder, a danger we'll explore next. This wasn't just a local event, it was a continental-scale freeze. Tens of millions were affected, from Texas oil fields to the mid-Atlantic coast. The polar vortex's signature was unmistakable. It's a powerful lesson in how far-reaching a single atmospheric disruption can be. During cold snaps, you'll often notice two different temperatures reported, the actual air temperature and the feels-like temperature, which is also known as the wind chill. While the air temperature tells you how cold the air is, the wind chill gives you a better idea of how cold it will actually feel on your skin when you step outside. Wind chill measures how quickly your body loses heat when wind strips away the thin layer of warmth next to your skin. This invisible layer acts like a natural barrier, but when the wind picks up, it blows that warmth away, making you feel much colder than the air temperature alone would suggest. The faster the wind, the faster you lose heat, making it feel much colder than the thermometer says. Even a gentle breeze can make a big difference, but strong winds can dramatically increase the risk of cold-related health issues. For example, if the air temperature is 10 degrees Celsius and the wind is blowing at 20 miles per hour, it can feel like 9 degrees Celsius. In these conditions, exposed skin can develop frostbite in as little as 30 minutes, making it crucial to take wind chills seriously. The air itself isn't actually colder, but your body loses heat much faster, which can quickly lead to hypothermia or frostbite if you're not properly protected. That's why forecasters emphasize wind chill in their reports. It's not just about comfort, but about your safety and well-being during extreme cold events. The National Weather Service calculates and issues wind chill warnings to help you prepare for dangerous conditions. These warnings are based on scientific formulas that combine wind speed and temperature to estimate the risk. When you hear a wind chill advisory, it means the combination of cold and wind is strong enough to be hazardous. It's a signal to take extra precautions and limit your time outdoors. To protect yourself, dress in warm layers, cover all exposed skin, and wear hats, gloves, and scarves. Try to keep moving and avoid staying outside for long periods. Understanding wind chill and how it affects your body can help you make smart choices and keep your family safe during extreme cold snaps. Remember, wind chill is more than just a number. It's science that saves lives by helping you stay prepared and protected in winter's harshest conditions. When extreme weather hits, the National Weather Service, NWS, is on the front lines. Their meteorologists work around the clock using computer models, radar, and satellite data to issue life-saving forecasts and warnings. With 122 local offices, they provide detailed alerts tailored to each region. Winter storm watches, warnings, and wind chill advisories help communities prepare and respond. The NWS partners with local media and emergency managers to spread the word quickly. Their work is a vital public service, often behind the scenes. Thanks to their efforts, millions get the information they need to stay safe. The NWS is our national weather watchdog, especially when the polar vortex comes calling. Here's the paradox. A warming Arctic may actually lead to more extreme winter weather in places like Texas. As the Arctic heats up faster than the rest of the planet, a process called Arctic amplification, the temperature difference between the pole and the equator shrinks. This weakens the jet stream, making it wavier and more likely to let Arctic air escape south. So, even if Arctic air is slightly warmer than decades ago, it can travel farther. Studies suggest these outbreaks will remain a feature of our winters for years to come. This doesn't contradict global warming. It's a symptom of a disrupted climate system. Climate change means more extremes, not just more heat. The link between a warming Arctic and southern cold snaps is a puzzle scientists are racing to solve. The future may hold more surprises. The 2026 Polar Vortex shows that climate change is about disruption, not just warming. Adding heat to the atmosphere makes the whole system more chaotic, like a pot of water bubbling on a stove. We get more extremes, stronger hurricanes, heavier rain, deeper droughts, and yes, sudden cold snaps. A single freeze in Texas doesn't disprove global warming. It's part of a bigger, more volatile pattern. Climate is the average of weather over decades, and the long-term trend is clear. The planet is warming, but within that trend, we'll see more volatility and unpredictability. Communities must prepare for both rare cold and intense heat. It's time to move beyond the idea of just warming and understand the reality of climate disruption. The polar vortex is a symptom, not a contradiction. Preparing for the future means expecting the unexpected. As the Arctic air retreats, one lesson stands out. Understanding our planet is essential. Meteorology and climate science help us anticipate, prepare for, and survive extreme events. From complex computer models to simple wind chill warnings, science keeps us safe. Staying informed and prepared is everyone's responsibility. Support for research and STEM education builds resilience for the future. Knowledge is power, especially when facing nature's extremes. The Earth is dynamic and interconnected. Respecting its forces is key. By asking questions and seeking answers, we empower ourselves and our communities. Science is our best tool for navigating a changing world, and that's why weather science matters, now more than ever.